You know, when you look at Saturn's largest moon, Titan, all you see is this hazy orange ball. But underneath those clouds, well, that's one of the solar system's biggest mysteries. It's this world that feels kind of like Earth, but totally alien at the same time. For decades, we had no idea what its surface looked like. But now we're finally getting a peek. So what have we actually found down there?
And really, that's the question that's been bugging scientists for years, right? What is hiding under that thick, soupy atmosphere? What kind of secrets is this weird little moon keeping from us?
So let's rewind a bit. Our journey to figure out Titan starts way, way back in 1655. And the name Titan is no joke. This moon is an absolute giant. We're talking bigger than the planet Mercury. But here's the crazy part. For centuries, even though it was this huge thing in the sky, it was a total black box, a complete mystery.
So, how do you solve a mystery like Titan? You send robots, of course. Over the decades, we've sent a whole series of explorers on this incredible journey. And each mission, from the very first flyby to the one we've got planned for the 2030s, has peeled back another layer of the onion, getting us closer and closer to the truth.
Okay, so our first proper hello to Titan was back in 1979. A spacecraft called Pioneer 11 was actually there to check out Saturn, but it swung by Titan for a quick look. Now, it couldn't see through those thick clouds, not at all. But what it did manage to find? Oh yeah, it was fascinating.
The very first big clue Pioneer sent back was a real jaw-dropper. Titan has this thick, dense atmosphere, and it's mostly nitrogen. Now, does that ring a bell? It totally should. Earth's atmosphere is mostly nitrogen too. I mean, finding another world in our solar system with an atmosphere so similar to ours, that is the kind of thing that makes scientists drop everything and pay attention.
But wait, there's more. Pioneer also picked up signs of hydrocarbons, methane to be specific. And this was a huge deal, a real game changer. Why? Because hydrocarbons aren't just, natural gas for your stove. They are the fundamental building blocks of life. We're talking this stuff that makes up DNA and proteins, the very foundation.
And get this, Pioneer also found that Titan's gravity is super weak, way weaker than you'd expect. So you've got this low gravity combined with a super thick atmosphere, and the physics get weird. It's so thick and the gravity is so low that if you were there in a wingsuit, you could literally just jump off a cliff and fly, like a bird. Just flap your arms and fly. How wild is that?
Okay, so we had these amazing clues, but we still couldn't see anything. We had to wait another 25 years for the technology to get good enough. Finally, in 2004, the Cassini spacecraft showed up, and this thing was kitted out with radar and special cameras that could actually see right through that orange smog. And what it saw was absolutely mind-blowing.
First things first, the temperature. It is bone-chillingly cold on Titan. We're talking an average of -179 degrees Celsius. But that number, as cold as it is actually the magic number. It's the perfect temperature for all that methane we talked about to exist not just as a gas in the air, but as a liquid.
And that simple fact leads to one of the most incredible discoveries in the entire solar system. Titan has a weather cycle, just like Earth. You know how water evaporates from our oceans, forms clouds, and then rains back down? Well, Titan does the exact same thing, but with liquid methane. It evaporates, forms methane clouds, and then it rains liquid methane, which carves out rivers and fills up massive lakes and seas. It's an alien Earth.
Seeing this surface with radar was amazing. But scientists, seeing isn't enough. They wanted to touch it. So Cassini wasn't traveling alone. It had a little buddy tucked away, the Huygens probe. Its one and only job was to detach, parachute through those crazy clouds, and land smack dab on the surface of Titan.
So, in January 2005, it was showtime. Huygens dropped into the atmosphere, and as it punched through that thick orange haze, we, humanity, got our first real look at this alien landscape. And what a view! There were bright mountains, but they were made of water ice, dark valleys, and this incredible network of river channels, some of them huge, all clearly carved out by flowing liquid. The probe landed with this gentle thud, right in what looked for all the world like a dried-up riverbed. The view was it was so familiar, it was weird. You could see these rounded stones, smoothed by a current. But they weren't rocks, they were chunks of rock-hard water ice. And the sand on the river bottom, it was actually this soft, snowy stuff made of hydrocarbons. Everything looked right, but was made of the wrong stuff. So we've got methane rivers and ice mountains. Cool. But that wasn't the end of the story. Not even close. Turns out, the biggest secret on Titan was still hidden.
buried deep, deep underground. This brings us to a really important question. We found the building blocks of life, right? The hydrocarbons. But for life as we know it, you need something for those building blocks to float around and mix in. You need a solvent. On Earth, that's liquid water. But on Titan, the surface is frozen solid. So, where's the water?
Well, the clue came from a place you might not expect. Volcanoes. But these aren't the fiery volcanoes we have on Earth. These are cryovolcanoes, ice volcanoes. Instead of spewing out hot lava, they erupt a cold, slushy mix of water and ammonia. Now, why ammonia? Think of it like the salt we put on icy roads. Ammonia acts as a natural antifreeze for water, letting it stay liquid even when it's insanely cold.
And this is where the story just gets unbelievable. The fact that these ice volcanoes exist can only mean one thing. It means that deep beneath that solid ice crust, there's a slushy layer. And beneath that, get ready for it, there is a massive planet-wide ocean of liquid water. A huge ocean, kept from freezing by a little bit of heat from the core and all that ammonia antifreeze. Wow.
Okay, let's just pause and take stock here. We've got the building blocks of life, hydrocarbons. On the surface, we've got a vast ocean of liquid water down below, and we've got ice volcanoes that could be mixing the two together. All the ingredients, right there in one place. So what do you do next?
I mean, really think about this. Titan has the trifecta for life as we know it. You've got the building blocks, you've got the liquid solvent, and you've got a way for them to mix. It has everything scientists think you need to get life started. This makes Titan like one of the absolute top places in the solar system to go looking for life.
And that is exactly why we have to go back. So let me introduce you to Dragonfly. This thing is not a rover. Oh no, it's a nuclear-powered, car-sized helicopter drone. A quadcopter. Why a drone? Well, remember that low gravity and thick atmosphere we talked about? It makes Titan the single best place in the solar system to fly. So Dragonfly will be able to just hop around the surface, flying for miles at a time. It'll go from the dunes to an impact crater, landing, taking samples, analyzing them right there. It's basically a flying chemistry lab, and its whole mission is to hunt for signs of life, past or present. It's slated to get there in 2034.
So here we are. After all these decades of glimpses and discoveries, we've found this world that's so strangely like our own. A world that has all the right ingredients in the pot. Which leaves us with the biggest question of all. Is Dragonfly going to be the mission that finally finds something? Could the answer to that ancient question, are we alone, be waiting for us on a